Hello and welcome to the Sleepy Equation. As you settle into your quiet space tonight, let me tell you about the invisible magic that's surrounding you right now, the gentle hum of electromagnetic waves that make modern life possible. If you're watching this on a screen, know that the very words you're seeing traveled as radio waves through the air or as pulses of light through fiber optic cables. That warm glow from your lamp? Those are electromagnetic waves your eyes perceive as visible light. Even the Wi-Fi signal keeping you connected moves as unseen waves, dancing around you at the speed of light. Before we drift deeper into the story, I'd love to know, where are you experiencing these waves tonight? Are you in a city buzzing with radio signals? Or somewhere quieter, where the star's natural electromagnetic whispers might still be heard? Leave a comment sharing your corner of this wave-filled world. Now, make yourself comfortable as we explore how humanity first discovered these hidden ripples in the universe's fabric, from the spark that jumped between wires in a lab, to the realization that light itself is just one note in an enormous electromagnetic symphony. There is something profoundly humbling about the way the universe speaks to us, not in words, but in waves. Long before we could hear them, they were there, threading through the empty spaces between stars, dancing across the skin of the Earth, even passing through our bodies without a whisper of acknowledgement. These are the electromagnetic waves, the silent messengers of light and energy. And their discovery did not just change science, it changed the very fabric of human existence. To understand how, we must begin not with the roar of revelation, but with the quiet, almost imperceptible stirrings of curiosity that first led us to listen. Imagine for a moment the world before we knew, a world where the night was truly dark, where distant voices could not leap across oceans in an instant, where the stars were mysteries, untouchable by human hands. It was a world bound by the limits of the senses, where the invisible remained forever hidden. And then, slowly, like the first light of dawn creeping over the horizon, came the realization that there was more, so much more, than what the eye could see or the ear could hear. The story of electromagnetic waves is not just a tale of scientific triumph, it is a story of learning to hear the universe in a language we never knew existed. It began with a question, as all great discoveries do. In the early 19th century, a Danish scientist named Hans Christian Ørsted noticed something peculiar. A compass needle twitched when he turned on an electric current nearby. It was a small thing, almost insignificant, a flicker of movement where none should have been. But in that flicker lay the seed of a revolution. Electricity and magnetism, once thought to be entirely separate forces, were whispering to each other. The idea that these two phenomena were intertwined would eventually unravel the mystery of light itself. But first, it would take the gentle persistence of a few curious minds to follow the thread. Michael Faraday, a man with little formal education but an imagination vast enough to hold the universe, picked up where Ørsted left off. In the quiet of his laboratory, Faraday played with magnets and coils of wire, watching as electricity emerged from nothingness, as if conjured by the motion itself. He called it electromagnetic induction, a phrase that belies the poetry of what he saw, the birth of current from the marriage of movement and magnetism. Faraday did not just discover a new phenomenon, he glimpsed the hidden unity of nature, a harmony that would later sing to us across the void. And then came James Clerk Maxwell, a thinker who saw the world in equations. Where others saw disconnected phenomena, Maxwell saw a tapestry, and he wove the threads together with mathematics. His equations were not just calculations, they were prophecies. They declared with quiet certainty that electric and magnetic fields could travel through space as waves. Waves that moved at the speed of light. It was a staggering idea. Light itself was an electromagnetic wave. And if that were true, then there must be others, unseen and unknown, waiting to be discovered. But how does one find something invisible? How does one listen for a voice that has never spoken? The answer came in the form of a man named Hertz, who built a simple device to catch these phantom waves. A spark jumped between two metal spheres, and across the room, another spark answered. No wires connected them, no visible force passed between, just the silent ripple of Maxwell's waves, crossing the empty air as if it were nothing at all. Hertz had done it. He had heard the universe whispering, and in that moment, the world grew larger. This was only the beginning. The discovery of electromagnetic waves did not just add a new chapter to the book of science, it rewrote the story of humanity. It gave us radio, television, the ability to see the heat of stars and the cold of space, the power to heal with X-rays and communicate across continents. But more than that, it changed the way we see ourselves. We are no longer creatures bound by the limits of our senses. We have learned to hear the songs of the cosmos, to see the invisible, to reach beyond the confines of our bodies and touch the universe in ways our ancestors could never have dreamed. And so, as we start to drift into sleep, let us remember that we are surrounded by waves, waves that carry voices, images, the warmth of the sun, the glow of distant galaxies. They are the silent symphony of existence, playing just beyond the edge of perception. And though we cannot hear them, they are there, humming softly in the dark, connecting us to everything. If you close your eyes and listen, you can almost hear it, the quiet hum of the world speaking to itself. It is there in the faint crackle of a radio tuning between stations, in the soft glow of a smartphone screen lighting up in the dark, in the distant pulse of satellites orbiting high above the Earth. These are the echoes of electromagnetic waves, the invisible threads that stitch our modern world together. Their discovery did not just unlock the secrets of light, it wove a web of connection that now cradles all of human civilization. And to understand how deeply they shape our lives, we must step back into a time when the world was still vast, when silence stretched uninterrupted across continents, and when loneliness was the price of distance. Picture for a moment the year 1895. Guglielmo Marconi, a young Italian inventor, stands in a quiet room adjusting a strange device of wires and metal. He presses a switch, and somewhere unseen, a spark leaps across a gap, a spark that carries no sound, no light, nothing but the faintest tremor of energy. Yet moments later, across the room, a needle jumps. A signal has been sent, without wires, without words, without anything but the silent breath of electromagnetic waves. It was a simple experiment, but in that simplicity lay the seed of a revolution. For the first time in history, human thought could leap across empty space, untethered by the limits of cables or the speed of a messenger. Marconi did not know it then, but he had just taken the first step toward shrinking the world. His early experiments grew into the first practical radios, and soon messages could cross oceans in the time it took to blink. Ships at sea, once isolated and vulnerable, could now call for help across the void. News, once carried by horse or ship, now flew on invisible wings. The waves that Hertz had coaxed into existence in his laboratory were no longer just a scientific curiosity. They had become the lifelines of nations. But more than that, it changed the way we see ourselves. It changed the way we see our place in the universe, because these waves have unlocked so much. The waves that Hertz discovered in his laboratory have taught us so much about the universe. The waves that he used to discover electromagnetic waves have not just unlocked the secrets of light, it has unlocked the universe itself. And it has unlocked our place in the universe because these waves have transformed the way we live. We are no longer creatures bound by the limits of our senses. We have learned to hear the songs of the cosmos, to see the invisible, to reach beyond the confines of our bodies, and touch the universe in ways our ancestors could never have dreamed. And we have learned to listen to the songs of the cosmos. The songs of the cosmos are the electromagnetic waves. They are everywhere and nowhere at once. They pass through walls, through mountains, even through the emptiness of space, yet they leave no trace of their passing. A single broadcast from a radio station fans outward in an ever-expanding sphere, growing fainter and fainter, but never truly vanishing. Somewhere, perhaps, a fragment of that signal still drifts among the stars, a ghost of human voices cast into the void decades ago. The waves we send today may outlast us, carrying our words and songs into a future we will never see. And then, in the early 20th century, came the next great leap, the realization that these waves could carry not just sound, but images. The flickering glow of television screens brought distant events into living rooms, turning the world into a shared story. A moon landing, a concert, a breaking news story, all of it could be witnessed simultaneously by millions, as if the boundaries of space had dissolved. The waves that once seemed like a scientific oddity had become the fabric of collective memory, stitching together the experiences of strangers into something like shared consciousness. Yet, for all their power, electromagnetic waves remain gentle servants. They do not demand attention. They do not shout. They simply exist, humming in the background of our lives, unnoticed until they are needed. Your Wi-Fi router, your microwave, the GPS guiding your way home, all of them rely on these silent messengers, each operating at a different frequency, each performing its task without fanfare. Even the warmth of sunlight on your skin is the caress of electromagnetic waves, a reminder that this force is not just a tool, but a fundamental part of nature itself. So tonight, as you lie in the quiet darkness, take a moment to imagine the waves moving through the air around you, the radio signals, the Wi-Fi, the faint echoes of broadcasts from decades past, all of them swirling together in an endless dance. We have learned to harness them, to shape them, but they were here long before us, and they will remain long after. They are the silent symphony of connection, the unseen hand that binds the world together, and in their constancy, there is a kind of comfort, a reminder that no matter how isolated we may feel, we are never truly alone. There is a kind of magic in learning to see what was always invisible. Imagine standing in a pitch-black room, your hands outstretched, knowing something is there but unable to perceive it, until suddenly a switch is flipped, and the unseen becomes clear. This is what electromagnetic waves gave us, not just new tools, but new senses. They taught us that light is more than what meets the eye, that the spectrum of reality extends far beyond the narrow slice our biology allows us to perceive. And in doing so, they quietly revolutionized medicine, astronomy, and our understanding of life itself. The first clues came from an accidental discovery in 1895. Wilhelm Röntgen, a German physicist, was experimenting with cathode rays when he noticed something peculiar. A screen coated with fluorescent material began to glow, even though it was shielded from the cathode rays. Something else was penetrating the barrier, something invisible. Röntgen called them X-rays, using X for their unknown nature. But what he had truly uncovered was a new way of seeing. For the first time, flesh became translucent, and bones emerged from the shadows like ghosts. A doctor could now peer inside a living body without a single incision, diagnosing fractures and tumors that had once been mysteries. It must have felt like sorcery to hold up a photographic plate and see through skin as if it were glass. Yet X-rays were just the beginning. As scientists mapped the electromagnetic spectrum, they realized that every frequency told a different story. Infrared waves, longer than visible light, carried the warmth of living things. With special cameras, we could suddenly see the heat signature of a feverish child or the thermal footprint of a forest fire smoldering beneath the surface. Ultraviolet light, shorter and more energetic, revealed hidden patterns in flowers that guide bees to nectar, and the faint glow of distant stars birthing new planets. The universe had been speaking in these wavelengths all along. We simply hadn't known how to listen. Perhaps the most profound gift of this expanded vision came from the stars. In the 1930s, a radio engineer named Carl Jansky was troubleshooting static in transatlantic phone lines when he noticed a strange, persistent hiss. After months of tracking, he realized the source wasn't earthly interference, it was the center of our galaxy singing in radio waves. This was the birth of radio astronomy, a new way to observe the cosmos. Visible light shows us only a fraction of celestial objects. Dust clouds and great distances obscure the rest. But radio waves slip through these barriers effortlessly, carrying whispers from quasars billions of light years away and the faint afterglow of the Big Bang itself. The night sky, once a static tapestry of pinpricks, became dynamic, a chorus of processes too violent, too distant, or too cold for our eyes to witness. Back on Earth, these discoveries quietly transformed everyday life. Microwave ovens, originally developed from radar technology, use specific frequencies to make water molecules dance, heating food from within. Airport security scanners employ millimeter waves to detect concealed objects without invasive searches. Even the weather maps on your phone rely on satellites reading infrared and microwave signals from the atmosphere. The waves that once seemed like laboratory curiosities now shepherd us through our days, invisible guardians smoothing the rough edges of existence. But the true wonder lies in how these technologies mirror natural processes that predate humanity by eons. The pit viper hunts using infrared sensors, seeing the warmth of its prey. Migratory birds navigate using magnetoreception, sensing Earth's magnetic field, another manifestation of electromagnetism. In developing these tools, we didn't so much invent new capabilities as learn to emulate the wisdom already woven into life. The universe has always communicated through these waves. We simply needed time and curiosity to understand the language. As you rest tonight, consider this. Your body, too, is part of this silent conversation. The calcium in your bones absorbs X-rays differently than soft tissue, making medical imaging possible. Your cells repair themselves from UV damage every time you step into sunlight. Even the electrical impulses in your nervous system are a form of bioelectromagnetism, proof that these forces don't just surround us, they are us. The boundary between technology and nature blurs when viewed through the lens of electromagnetism, revealing a world far more interconnected than it appears. There is a particular kind of magic in realizing that every glance at the night sky is an act of time travel. When you look at the stars, you are not seeing them as they are, but as they were. Years, centuries, even millennia ago. The light now brushing your retina began its journey long before you were born. Electromagnetic waves are the universe's memory, its way of preserving moments across impossible gulfs of time and space. And when we learned to harness this property, we didn't just invent new technologies, we built bridges across epochs. The first person to truly grasp this temporal quality of light was none other than Albert Einstein. His theory of special relativity revealed a startling truth. The speed of light is the only constant in the universe. No matter how fast you move toward or away from a light source, its waves always reach you at the same speed. This simple fact has profound implications. It means light carries with it a perfect record of when and where it began. Every photon is a tiny time capsule, preserving the conditions of its birth across billions of years. Astronomers became the first time travelers. When Edwin Hubble pointed his telescope at distant galaxies in the 1920s, he noticed something peculiar. Their light was stretched toward the red end of the spectrum. This red shift wasn't just telling us galaxies were moving away, it was revealing the expansion of space itself. The farther we looked, the further back in time we could see. Today, our most powerful telescopes detect galaxies whose light has traveled 13 billion years to reach us. We're not just observing the early universe, we're receiving mail from the cosmic dawn, written in photons that began their journey when the first stars were still igniting. Meanwhile, another revolution was occurring on Earth. In 1965, two radio astronomers named Arno Penzias and Robert Wilson were troubleshooting persistent static in their antenna at Bell Labs. After eliminating every possible source of interference, even cleaning out pigeon nests, they made an astonishing discovery. The static wasn't noise, it was signal. They had accidentally detected the cosmic microwave background, the afterglow of the Big Bang, cooled over 13.8 billion years into faint microwaves that permeate all of space. This was the oldest light in existence, a baby picture of the universe when it was just 380,000 years old. The electromagnetic spectrum had given us a time machine capable of looking back to creation itself. Yet even as we peered into the past, these same waves were carrying our present into the future. The first radio broadcasts ever transmitted, Marconi's experiments, early voice transmissions, even Hitler's 1936 Olympic broadcast, have all been traveling outward at light speed for decades. They form an expanding bubble of human culture radiating through the galaxy. The first episode of I Love Lucy is now over 70 light years away, potentially being decoded by alien civilizations, or more likely, lost in the interstellar noise. Every tweet, every satellite transmission, every radar pulse adds to this ephemeral archive of our species, destined to outlast not just our civilization, but perhaps our planet. The most poetic application of this temporal quality might be in medicine. Magnetic resonance imaging, or MRI machines, use powerful radio waves to map the interior of the human body. But the signals they detect come from hydrogen atoms that have existed since the birth of the universe. In that brief moment inside the scanner, your body becomes a bridge between cosmic history and medical science. Ancient atoms singing their positions in radio waves that a computer translates into images. It's a reminder that the hydrogen in your body is older than the stars, communicating its location through the same electromagnetic forces that govern the cosmos. Consider this beautiful paradox. The same phenomenon that lets doctors examine your bones also carries whispers from the beginning of time. The device in your pocket that connects you to global conversations operates on principles that govern quasars at the edge of the observable universe. Electromagnetic waves have made us citizens of deep time, able to look backward across billions of years while simultaneously casting our own messages into the cosmic future. There comes a moment in every great scientific journey when the boundary between the physical and the metaphysical begins to blur, when what we touch and what we imagine merge into something new. The story of electromagnetic waves carries us gently to this threshold, where particles behave like waves, where empty space hums with invisible energy, and where the solid world we know dissolves into vibrations in an endless field. This is not just a story of discovery, but of awakening to a universe far more mysterious and interconnected than our ancestors ever dreamed. Picture the scene. Paris, 1924. A young prince named Louis de Broglie sits quietly in his study, contemplating the nature of light. Scientists are at war with themselves. Some experiments prove light is a wave, others insist it must be particles. De Broglie has a radical thought. What if it's both? His hypothesis will soon shake the foundations of physics, suggesting that all matter, from photons to planets, has wave-like properties. The implications are staggering. The chair you sit on, the book in your hands, even your own body, all are surrounded by invisible wave patterns, like ripples in a pond we cannot see. Electromagnetism has led us to a truth both beautiful and unsettling. At its core, reality is far less solid than it appears. This wave-particle duality reveals itself most poetically in the phenomenon of interference. Shine light through two narrow slits, and instead of creating two bright lines, it produces a shimmering pattern of light and dark bands, the signature of waves interacting with themselves. But here's the wonder. Even when you send single photons through the slits one at a time, the pattern still emerges. Each particle seems to pass through both slits simultaneously, interfering with itself like a ghostly echo. The electromagnetic field, it seems, is not just a medium for waves, it's a realm where possibilities exist in superposition, where an electron can be here and there, until observed. Quantum mechanics will later formalize these ideas, but their roots lie in those early experiments with light and its mysterious dual nature. The implications ripple outward. If light waves can behave as particles, and particles as waves, what does this say about the fabric of reality? Max Planck's work on blackbody radiation reveals another astonishment. Energy comes in discrete packets called quanta. The smooth, continuous universe of Newton gives way to a pixelated reality where change happens in jumps rather than slides. Suddenly, the comforting solidity of classical physics dissolves into a quantum sea of probabilities. The electromagnetic field becomes understood not as mere emptiness, but as a frothing ocean of virtual particles blinking in and out of existence, a quantum foam underlying all of reality. Yet for all its strangeness, this new view brings unexpected unity. Einstein's equations show that electricity, magnetism, and even the force we call gravity are simply different manifestations of space-time's geometry. The electromagnetic field becomes recognized as one aspect of a deeper, more fundamental field, the quantum field, that gives rise to all particles and forces. What we perceive as separate phenomena are but different notes played on the same cosmic instrument. The radio waves carrying music to your speaker, the light illuminating these words, the chemical bonds in your body, all are expressions of this underlying field vibrating at different frequencies. Perhaps most remarkably, these discoveries change our understanding of emptiness itself. Where once we thought of space as a void, we now know it teems with potential. The electromagnetic field exists everywhere, even in what we call a vacuum. Between the atoms in the air, in the deepest reaches of intergalactic space, the field persists, ready to ripple with waves when disturbed. This means that what we perceive as nothing is in fact a rich medium, pregnant with possibility. The static on an untuned radio is partly the hiss of the universe's birth. Photons from the Big Bang, stretched by cosmic expansion into microwaves, still detectable after 13.8 billion years. As we trace the ripples of electromagnetic discovery through human consciousness, we arrive at a quiet revelation. The true power of these invisible waves lies not just in what they can do, but in how they have transformed the way we think. Light has always been more than illumination. It is the first metaphor, the original symbol of understanding. I see, we say when we comprehend, as if vision and knowledge were the same. But the story of electromagnetism has gently unraveled this ancient equation, teaching us that the most profound truths often lie beyond what the eyes can see. Consider the artists first. those sensitive barometers of cultural change. In the wake of Maxwell's equations, the Impressionists abandoned strict realism to paint light itself. Not objects, but the shimmering interplay of photons and perception. Monet's water lilies dissolve into radiant vibrations, just as physics revealed solid matter to be mostly empty space buzzing with electromagnetic energy. Later, the futurists would attempt to depict motion as a continuum, inspired by the understanding that a moving electron emits electromagnetic waves. And when James Turrell creates installations bathing viewers in monochromatic light, he taps into the same wonder that gripped Newton when he split sunlight through a prism, the awe before light's hidden dimensions. Philosophers, too, found their certainties softened by these discoveries. The 18th century's clockwork universe, where every effect had a visible cause, gave way to a reality where invisible fields mediate all interactions. Heidegger would later describe technology as a way of revealing, and nowhere is this more apparent than in our electromagnetic tools. The radio doesn't just transmit sound, it reveals that the air around us is already full of voices we cannot hear. The MRI scanner doesn't just image the brain, it demonstrates that thought itself is an electromagnetic phenomenon, neurons communicating via precisely timed electrical pulses. We've come to understand that consciousness may be less like a solid thing and more like a standing wave pattern, constantly shifting yet maintaining its form. This revolution in thought reaches its most personal expression in how we understand vision itself. For centuries, we imagined sight as a passive process, the world imprinting itself on our eyes. But quantum electrodynamics reveals a more intimate dance. When you look at a rose, sunlight photons have traveled 8 minutes from our star, bounced off the flower's petals, themselves shaped by molecular bonds that are fundamentally electromagnetic, and now interact with the electrons in your retina. These interactions are so delicate that the very act of seeing changes what is seen. The crimson hue you perceive isn't an absolute property of the rose, but a conversation between quantum fields, an agreement struck between the flower's electrons and your own. The most profound shift may be in our relationship with the invisible. Ancient cultures worshipped deities of the sun and storm, visible powers. Our modern world reveres the unseen spectrum, the radio waves that carry our prayers for connection, the infrared that reveals heat signatures in darkness, the ultraviolet that both damages and energizes life. We've developed a sixth sense for these hidden forces, not biologically, but technologically. A teenager instinctively understands that their phone connects to something unseen, that Wi-Fi permeates walls, that satellites overhead are always whispering to their devices. This intuitive grasp of the electromagnetic world marks perhaps the most significant evolution in human cognition since the invention of written language. As night deepens and your eyelids grow heavy, consider this final gift of the electromagnetic age, the dissolution of boundaries. The same physics that enables global communication has taught us that separation is an illusion. Your body is a temporary pattern in eternal fields. Your thoughts flickers in an ancient conversation between matter and energy. The screen before you, the distant stars, the memories playing behind your closed eyes, all are variations on the theme of electromagnetism's endless song. In the quiet hush of a hospital room, electromagnetic waves perform their most tender miracles. Here, where life hangs in delicate balance, the same forces that power our cities and light our screens become gentle healers, their invisible touch mending broken bones, revealing hidden ailments, and sometimes even soothing troubled minds. The story of medicine's electromagnetic revolution is one of humanity's most compassionate chapters, where our understanding of waves became a balm for suffering. The first medical miracle came unexpectedly in 1895 when Wilhelm Röntgen noticed his cathode ray tube could expose photographic plates through solid objects. Within weeks of his discovery, X-rays were being used to locate bullets in wounded soldiers and diagnose fractures without surgery. But the true wonder lay in what this revealed about our bodies. Beneath the skin, we are all luminous creatures, our skeletons casting shadows of varying density, our organs pulsing with electrical rhythms. For the first time, physicians could see inside the living body without cutting, a revolution as profound as the invention of the microscope. As the 20th century progressed, electromagnetic healing grew more sophisticated. Diathermy machines used radio waves to generate deep heat in tissues, easing arthritis pain. Later, pulsed electromagnetic field therapy would accelerate bone healing, its gentle pulses mimicking the body's natural electrical signals that stimulate cellular repair. Even today, researchers explore how specific frequencies might help regenerate nerves or reduce inflammation. The body responding to electromagnetic whispers we're only beginning to understand. Perhaps the most profound medical application came with the development of magnetic resonance imaging. Unlike X-rays, which simply pass through tissue, MRI machines listen to the body's own electromagnetic responses. When placed in a powerful magnetic field, the hydrogen atoms in your body align like tiny compass needles. A pulse of radio waves then knocks them momentarily out of alignment, and as they return to equilibrium, they emit faint radio signals of their own, a subatomic choir singing the body's secrets. A computer translates these whispers into breathtakingly detailed images, revealing tumors smaller than a pea, tracing the delicate branches of coronary arteries, or capturing the soft glow of a thinking brain in action. The brain itself, that most mysterious organ, yields its secrets to electromagnetic investigation. Electroencephalography records the brain's electrical symphony, each thought and sensation reflected in shifting wave patterns. Transcranial magnetic stimulation uses focused electromagnetic pulses to gently nudge neural activity, offering relief for depression when medications fail. And in research labs, scientists are learning to decode neural signals, allowing paralyzed patients to control robotic limbs with their thoughts. A direct marriage of biology and electromagnetic technology that verges on science fiction. Yet for all these technological marvels, the most moving applications are often the simplest. The fetal Doppler that lets expectant parents hear their baby's heartbeat relies on ultrasound, high-frequency sound waves reflecting off tiny chambers of a developing heart. The pacemaker that keeps a failing heart rhythm uses electrical impulses no stronger than those the body generates naturally. Even the humble light box used to treat seasonal affective disorder works by mimicking sunlight's spectrum, its photons triggering biochemical changes that lift mood. As you rest tonight, consider the quiet miracle. Your body is an electromagnetic being. Your heart's rhythm is governed by electrical impulses. Your nerves communicate via voltage changes. Even your cells maintain electrical potentials across their membranes. The same forces that power stars and smartphones animate your very flesh. And when medicine harnesses these forces, it's not imposing something foreign, it's speaking your body's native language, the electromagnetic tongue of life itself. Far beyond our atmosphere, where Earth's blue fades to the black of interplanetary space, electromagnetic waves compose a silent symphony on scales both unimaginably vast and infinitesimally small. This is where our story expands from human-scale wonders to cosmic revelations, where we discover that the same physics governing our smartphones also orchestrates the dance of galaxies. The universe, it turns out, is not just filled with electromagnetic phenomena, it is electromagnetic phenomena, from the quantum flutter of atoms to the slow radio wail of colliding galaxy clusters. The first notes of this cosmic symphony were heard accidentally in 1931 when Carl Jansky, an engineer at Bell Labs, was investigating static that interfered with transatlantic radio communications. After months of patient observation, he traced some of the noise to an unexpected source, the center of our Milky Way galaxy. The universe, it seemed, was singing in radio waves. This discovery birthed radio astronomy, allowing us to see celestial objects invisible to optical telescopes. Cold hydrogen clouds, where stars are born, the remnant glow of the Big Bang, pulsars spinning with lighthouse regularity. Each segment of the electromagnetic spectrum reveals a different movement in this cosmic composition. Infrared telescopes like Spitzer peer through dust clouds to witness stellar nurseries. X-ray observatories like Chandra captured the violent deaths of stars as supernovae, or the unimaginable energies near black holes. Gamma-ray detectors trace the most energetic events in the universe, colliding neutron stars, active galactic nuclei, and mysterious gamma-ray bursts that outshine entire galaxies for brief moments. Together, these instruments reveal a universe far more dynamic and varied than our eyes alone could perceive. The most profound revelation came in 1964 when Arno Penzias and Robert Wilson at Bell Labs detected a persistent microwave hiss coming equally from all directions, the cosmic microwave background. This was the afterglow of the Big Bang, the moment 380,000 years after creation, when the universe cooled enough for atoms to form, releasing photons that have been traveling ever since. The CMB is more than just ancient light. It's a baby picture of the cosmos, its slight temperature variations revealing the density fluctuations that would eventually grow into galaxies and galaxy clusters. Modern instruments, like the Planck satellite, have mapped these variations with exquisite precision, revealing a universe that's 4.9% ordinary matter, 26.8% dark matter, and 63.8% dark energy, numbers that humble our understanding. Even more remarkably, by studying the polarization patterns in the CMB, scientists have found evidence for cosmic inflation, the theory that the universe underwent exponential expansion in its first fraction of a second. The electromagnetic waves from this primordial era carry messages across 13.8 billion years, whispering secrets about creation itself. Yet, the cosmic symphony isn't just about looking backward. Right now, neutrinos from the sun's core are passing through your body at nearly the speed of light. Gravitational waves from colliding black holes ripple space-time as they travel through Earth. And the radio transmissions of our civilization, from early TV broadcasts to modern radar, leak into space, forming an expanding bubble of human presence that's now over 100 light-years across. In this grand electromagnetic conversation, we are both listeners and, however faintly, speakers. Imagine this. Every photon that has ever entered your eyes is part of an unbroken chain stretching back to the Big Bang. The sunlight that warmed your skin today began its journey across space before you were born. The radio waves carrying distant stations have traveled through walls and mountains to reach you. You are immersed in and composed of the same electromagnetic phenomena that shapes stars and galaxies. The boundary between out there and in here is, at the quantum level, an illusion. We are all participants in the cosmic symphony, our very atoms vibrating in tune with the universe. The soft glow of your smartphone screen hides one of electromagnetism's most profound philosophical gifts, a mirror showing us that reality is far stranger than it appears. This isn't metaphorical. The very technology you hold depends on quantum electromagnetic phenomena that defy classical intuition. As we peel back another layer of our story, we discover that electromagnetic waves haven't just changed how we live, they've transformed our understanding of what it means to observe, to measure, and ultimately to exist. The revolution begins with a simple question: what is light doing when we're not looking at it? Quantum electrodynamics, developed in the mid-20th century, provides an answer so bizarre it still unsettles physicists. According to QED, light, and all electromagnetic phenomena, behaves differently when observed than when unobserved. In the famous double-slit experiment, electrons create an interference pattern characteristic of waves when no one watches which path they take, but act like particles when observed. This isn't just laboratory curiosity, it's the foundation of modern electronics. Your phone's processor relies on quantum tunneling, where electrons teleport through barriers they classically shouldn't penetrate. This quantum behavior extends to the very creation and destruction of light. When an electron in an excited atom drops to a lower energy level, it doesn't emit light smoothly, it releases a discrete photon whose properties are fundamentally probabilistic. The LED screen you are reading now exploits this phenomenon with billions of quantum events per second producing the light that forms these words. At this scale, electromagnetism reveals a universe built on probability clouds rather than certainties, where particles are also waves, where empty space seethes with virtual particles, and where observation itself shapes reality. The implications ripple through philosophy. The observer effect suggests that at quantum scales we cannot measure without disturbing. Heisenberg's uncertainty principle, a direct consequence of wave-particle duality, tells us we can never precisely know both a particle's position and momentum. The electromagnetic phenomena we've harnessed so effectively in technology thus reveal a universe that's fundamentally fuzzy at its core, where perfect knowledge is impossible, and where the act of measurement creates the very reality it seeks to discover. This quantum strangeness isn't confined to microscopic realms. Superconductivity, where electrical resistance vanishes at low temperatures, relies on electrons forming Cooper pairs that behave as quantum waves rather than particles. MRI machines depend on nuclear spins existing in quantum superposition. Even photosynthesis in plants appears to use quantum coherence to optimize energy transfer. The boundary between the quantum world and our classical experience is porous, with electromagnetic phenomena bridging the two. Perhaps most remarkably, quantum entanglement, where particles remain mysteriously connected across distances, relies on electromagnetic interactions. When two electrons become entangled, measuring one instantly determines the state of the other, no matter how far apart they are. This spooky action at a distance, as Einstein called it, has been experimentally verified over distances exceeding 1,200 kilometers. Future quantum networks may use this phenomenon to create unhackable communication channels, with photons carrying information secured by the laws of quantum physics itself. As you prepare to sleep tonight, consider this. The same quantum electromagnetic phenomena that seem so alien are happening right now within you. The chemistry of your brain relies on electron transitions. Your cells use electromagnetic potentials to regulate ion flows. Even your DNA structure is stabilized by electromagnetic forces between molecules. You are not just an observer of the quantum world, you are a product of it, a temporary pattern in an endless dance of energy and vibration. The screen before you, the stars above you, and the thoughts within you all emerge from this shimmering quantum electromagnetic sea. Beneath our feet and above our heads, in the soil and the sky, electromagnetic waves sustain an invisible ecology more intricate than any food web. This is the story we seldom hear, how natural electromagnetic phenomena predate human technology by billions of years, how life evolved not just in light's presence, but through its manipulation, and how our modern electromagnetic environment interacts with this ancient system in ways we're only beginning to understand. The first chapter of this story was written 3 billion years ago when cyanobacteria began harnessing sunlight through photosynthesis. This revolutionary act, converting electromagnetic energy into chemical energy, not only changed Earth's atmosphere by producing oxygen, but established the basic energetic currency of nearly all life. Every leaf, every blade of grass is a tiny solar panel, its chlorophyll molecules perfectly tuned to absorb blue and red light while reflecting green. The colors we see in nature are not accidents, but evidence of this ongoing electromagnetic conversation between life and light. But photosynthesis is just the most visible example. Migratory birds navigate using magnetoreception, the ability to sense Earth's magnetic field through specialized photoreceptors in their eyes. Sea turtles, salmon, and even fruit flies demonstrate similar abilities. Some researchers believe the sixth sense may involve quantum entanglement in cryptochrome proteins, where light-induced electron spins interact with geomagnetic fields, the same electromagnetic forces that guide our compasses, thus guide entire species across continents and oceans. Even at night, the electromagnetic ecology continues. Moonlight, sunlight reflected from lunar regolith, triggers coral spawning events so precisely timed they can be predicted down to the minute. Certain flowers reflect ultraviolet patterns invisible to humans, but guiding pollinators like runway lights. Fireflies communicate through bioluminescent flashes, their light production so efficient it inspired LED designs. And in the deep ocean where sunlight never reaches, creatures create their own light through chemical reactions, the only illumination in an eternal night. Human technology has added new layers to this ancient system. The very first radio transmissions disrupted natural electromagnetic silence. And today, our planet is wrapped in a cocoon of artificial signals. Some effects are concerning. Light pollution disrupts ecosystems and circadian rhythms, while certain radio frequencies may interfere with animal navigation. But there are hopeful signs too. Carefully designed electromagnetic fields can stimulate plant growth, and specific light wavelengths are being used to control invasive species without chemicals. The most profound realization is that we are not separate from this electromagnetic ecology, but deeply embedded within it. The human eye evolved to see the particular wavelengths our sun emits most strongly. Our circadian rhythms sync to Earth's 24-hour day-light-dark cycle through specialized ganglion cells that detect blue light. Even our skin's production of vitamin D depends on ultraviolet photons penetrating epidermal layers. From photosynthesis to vision, from magnetoreception to vitamin synthesis, life is electromagnetic at its core. As night falls and your body prepares for sleep, remember this. The dimming light outside triggers melatonin release in your pineal gland, just as it has for every ancestor in your evolutionary line. The stars above are electromagnetic beacons, whose light may have guided migrations long before compasses existed. And the quiet hum of technology around you, the Wi-Fi signals, the cellular towers, the satellites overhead, are simply the newest voices in an ancient conversation between life and electromagnetic fields that began when the first organisms learned to harvest sunlight. We are latecomers to this dialogue, but through science, we're beginning to understand its poetry. As our journey through the electromagnetic spectrum nears its end, we turn toward tomorrow. Not to predict, but to wonder. What new chapters will be written in humanity's relationship with these invisible waves? The clues lie in laboratories today, where scientists manipulate light in ways that border on alchemy, where quantum technologies promise revolutions we can scarcely imagine, and where our understanding of electromagnetism's fundamental nature continues to deepen. The most immediate frontier is the harnessing of terahertz waves. the largely unexplored band between microwaves and infrared. These frequencies can penetrate fabrics, but not metals, see through fog, but not walls, and identify chemical compositions by their unique absorption fingerprints. Future airport scanners might use terahertz imaging to detect concealed weapons without ionizing radiation, while medical applications could include detecting early-stage cancers by their altered water content. Agricultural monitors might assess crop health from drones, and art conservators could uncover hidden layers in masterpieces, all using this forgotten middle child of the electromagnetic spectrum. Quantum technologies promise to revolutionize our electromagnetic capabilities. Quantum radar could detect stealth aircraft by exploiting photon entanglement. Quantum LiDAR might map terrain with unprecedented resolution through forests or fog. And quantum communication networks could use entangled photons to create absolutely secure channels where any eavesdropping attempt would immediately be detected. These technologies don't just improve existing applications, they redefine what's possible by leveraging the quantum weirdness we explored earlier. Perhaps the most profound development will be the merging of biological and electromagnetic systems. Researchers are already developing optogenetics techniques where neurons are genetically modified to respond to specific light frequencies, allowing precise control of brain activity. Future therapies might use tailored electromagnetic pulses to accelerate healing, modulate mood, or even restore lost memories. On the horizon are direct brain-computer interfaces that translate neural activity into digital signals and vice versa, potentially giving humans new senses tuned to infrared, ultraviolet, or radio frequencies. The ultimate frontier remains fundamental physics itself. Despite all our advances, mysteries persist. Why does the electromagnetic force have precisely the strength it does? How is it unified with the other fundamental forces at high energies? What dark photons or other exotic particles might exist in the electromagnetic sector? Future particle accelerators and space-based observatories will probe these questions, potentially rewriting our understanding of electromagnetism's place in the cosmos. Yet for all these technological marvels, the greatest gift of electromagnetism may be philosophical. In teaching us that reality extends far beyond what we can see, that empty space teems with potential, and that observation shapes the observed, electromagnetic science has given us a humbler, more nuanced view of existence. The child who understands that their phone connects to invisible waves has already internalized a worldview radically different than any previous generation, one where the unseen is not imaginary, but fundamental. As you close your eyes tonight, imagine the future not as a foreign country, but as a continuation of this electromagnetic journey. The same forces that power stars and animate thought will light tomorrow's discoveries. The photons that began their journeys billions of years ago will continue arriving, each carrying fragments of cosmic history. And the endless conversation between matter and electromagnetic fields, the dance that gives form to everything from atoms to galaxies, will go on, with humanity as both participant and awestruck witness. In the quiet hours between midnight and dawn, when the world seems suspended between yesterday and tomorrow, we arrive at the final dimension of our electromagnetic story. Not a technological application or scientific principle, but a meditation on what it means to live in an electromagnetic universe. This is where physics meets philosophy, where discovery meets wonder, and where we recognize that our relationship with these invisible waves is ultimately a relationship with the deepest nature of reality itself. Consider the simple act of reading these words. Light from your screen enters your eyes, where photons are absorbed by retinal cells, triggering electrical impulses that travel along neurons. These signals are processed by your brain, itself an electromagnetic organ, into meaningful patterns. Simultaneously, radio waves from countless sources pass through your body unnoticed, while the Earth's magnetic field subtly influences biochemical processes in your cells. You are, in this moment, both an electromagnetic receiver and transmitter, a node in networks visible and invisible. This interconnectedness extends beyond the present moment. The sunlight that warms your skin left the solar photosphere 8 minutes ago. You're feeling the sun as it was, not as it is. The starlight you see on clear nights is ancient, some photons having traveled millennia before reaching your eyes. When astronomers study distant galaxies, they're looking back in time, watching electromagnetic messages from the cosmic past. Your very atoms were forged in stellar furnaces, their electromagnetic bonds preserving patterns established before Earth formed. The implications are humbling. The boundary between you and the universe grows thin when traced electromagnetically. Your body's elements were scattered across galaxies before being gathered by gravity and evolution. The energy in your cells was once sunlight, captured by plants. The electrical impulses in your brain resemble, in their basic physics, the signals pulsating through distant quasars. We are not just observers of the electromagnetic universe. We are its temporary configurations, localized eddies in an endless field. This perspective transforms how we view technology. Your smartphone isn't an alien imposition, but an extension of natural electromagnetic phenomena, a tool that, like photosynthesis or magnetoreception, harnesses fundamental forces for purposeful ends. The internet isn't separate from nature, but part of it, an ecosystem of information as real as any forest or coral reef. Our electromagnetic inventions are no less natural than a spider's web or a bird's nest, just more complex manifestations of the same universal principles. As dawn approaches, and your night of contemplation nears its end, let this thought linger. Electromagnetism has given us more than gadgets and conveniences. It has given us a new way to belong to the universe. Through its study, we've learned that we're woven into the cosmos at every scale, from quantum interactions to galactic structures. The same laws that govern distant stars operate in our fingertips. The same light that illuminates nebulae dances in our eyes. So when you next switch on a light, remember, you're not just illuminating a room. You're adding your voice to an eternal conversation between matter and energy that began with the first photons after the Big Bang. You're participating in the grand electromagnetic story that connects quarks to quasars, that binds past to present, and that reminds us we're not just in the universe, we are the universe perceiving itself across the luminous spectrum of existence. There exists a silent language older than words, written not in ink, but in the interplay of electric and magnetic fields, a cosmic syntax that predates life itself. This is the language of electromagnetism, the medium through which the universe communicates across the vast emptiness of space, and the foundation upon which all human communication is built. As we delve deeper into our exploration, we discover that these waves have not just changed how we speak to one another, but have fundamentally altered what it means to communicate at all. Imagine the first spark of human language, a grunt, a gesture, a drawn symbol in the dirt. For millennia, communication remained tethered to the physical, sound waves traveling through air, marks pressed into clay, smoke signals visible across valleys. The distance a message could travel was limited by how far a voice could carry or how fast a horse could run. Then came the electromagnetic revolution, and suddenly, words could leap continents in the blink of an eye. The first telegraph messages, those bursts of current spelling out Morse code, were more than technological marvels. They were the initial cracks in the ancient barriers of time and space that had constrained human connection since our species began. But this was merely the prelude. With radio waves, humanity discovered it could broadcast not just discrete messages, but the full richness of human expression, voice, music, the subtle inflections that carry meaning beyond words. A symphony performed in Vienna could be heard simultaneously in New York and Tokyo. a president's address could comfort a nation in crisis. For the first time in history, collective experience transcended geography, creating what Marshall McLuhan would later call the global village, not through physical proximity, but through shared electromagnetic space. The transition from analog to digital communication represents another quantum leap in this ongoing story. When we video call a loved one on another continent, their image is broken into bits, sequences of ones and zeros that ride electromagnetic carriers through fiber optic cables or wireless networks. At the quantum level, these signals are themselves manifestations of the photon's wave-particle duality. The love in their eyes, the laughter in their voice, all are translated into this most universal of languages, transmitted at light speed and reconstructed perfectly at the other end. In this alchemy, electromagnetism becomes the ultimate translator, rendering all human experience into a form that can traverse the void. Yet, the most profound communication revolution may be happening within science itself. Modern astronomy is essentially the art of interpreting electromagnetic messages from the cosmos. The Hubble Space Telescope's stunning images are carefully constructed from photons that have traveled billions of years. Radio telescopes like ALMA in Chile listen to the millimeter wave whispers of molecular clouds where stars are born. Gravitational wave detectors, while not electromagnetic themselves, rely on laser interferometry, another electromagnetic technology, to sense ripples in space-time. Through these instruments, the universe tells us its story in the language of light across all frequencies. As you rest tonight, consider this. Every time you send a text or stream a song, you're participating in a conversation that began with the first light of the Big Bang. The same fundamental forces that allow you to say, "I love you" across oceans also let astronomers hear the birth cries of galaxies. Electromagnetism has given us not just new ways to communicate, but a new understanding of communication itself, as something boundless, instantaneous, and woven into the fabric of reality. Woven through the darkness of the cosmos is a luminous tapestry whose threads are electromagnetic waves, some visible, most invisible, all telling stories of creation, destruction, and the endless transformation of energy. This is the story of how our understanding of this tapestry has revealed hidden patterns in nature, connected seemingly unrelated phenomena, and given us a vision of reality more intricate and beautiful than we ever imagined. The first glimpses of this tapestry came from simple observations of light's behavior. Newton's prism experiments showed that white sunlight contained all colors, the first hint that light was more complex than it appeared. Later, Fraunhofer's discovery of dark lines in the solar spectrum revealed these were absorption features caused by elements in the sun's atmosphere. Suddenly, a simple beam of light became a cosmic fingerprint, capable of revealing the chemical composition of distant objects. Spectroscopy was born, the art of reading these electromagnetic signatures, and with it, our ability to understand the universe's building blocks across cosmic distances. As spectroscopy advanced, astonishing connections emerged. The same spectral lines observed in laboratory flames were found in starlight, proving that the elements on Earth existed throughout the cosmos. The nebulium lines, observed in gaseous nebulae, initially thought to represent a new element, were eventually shown to be forbidden transitions of ionized oxygen, a revelation requiring quantum mechanics to explain. Even the redshift of distant galaxies, which revealed the universe's expansion, was detected through the shifting of these spectral signatures. The electromagnetic spectrum had become nature's barcode, encoding information about temperature, composition, velocity, and more in the precise patterns of emission and absorption. This tapestry extends far beyond visible light. radio astronomers discovered complex organic molecules in interstellar space by their microwave signatures, the same molecules that form life's basis on Earth. Infrared observations revealed protoplanetary disks around young stars, their heat signatures showing planets in the process of formation. X-ray telescopes uncovered the violent universe, black holes accreting matter, neutron stars spinning with unimaginable density, galaxy clusters filled with million-degree gas. Each portion of the electromagnetic spectrum reveals a different layer of cosmic reality, like separate instruments in an orchestra playing the same grand composition. The most profound realization is that these seemingly separate phenomena are all connected through electromagnetic processes. The nuclear fusion powering stars produces gamma rays that gradually transform into visible light as they pass through stellar material. Supernova explosions create shock waves that accelerate particles to relativistic speeds, generating synchrotron radiation across the spectrum. Even the humble aurora, those dancing lights in polar skies, are electromagnetic phenomena caused by solar particles interacting with Earth's magnetic field and atmosphere. Consider this. Your body, too, is part of this luminous tapestry. Your calcium in your bones absorb X-rays differently than soft tissue. Your body radiates infrared heat according to precise thermal laws. Your electrical rhythms of your heart and brain produce electromagnetic fields detectable by sensitive instruments. You are not separate from the cosmic electromagnetic dance. You are a living, breathing manifestation of it, a temporary constellation of atoms emitting and absorbing photons in the grand symphony of existence. In the silent laboratories of the cosmos and the bustling research centers of humanity, a quiet alchemy persists, the transformation of electromagnetic energy from one form to another, the endless dance of photons being created, destroyed, and reborn in new configurations. This is the story of how we learn to harness these transformations, turning sunlight into electricity, electricity into light, and in the process, reshaping civilization itself. The first ons was that light could create electricity. In 1839, 19-year-old Edmund Becquerel observed that certain materials produced small electric currents when exposed to light, the photovoltaic effect. It would take over a century before this observation became practical solar power, but the principle was revolutionary. Electromagnetic energy could be directly converted into electrical energy. Today's solar panels, though vastly more efficient, operate on the same basic principle: photons liberating electrons, sunlight becoming current. The same nuclear fusion reactions that power stars now power our homes through this elegant transformation. The reverse process, electricity becoming light, underwent its own evolution. Edison's incandescent bulbs worked by resisting the flow of electrons until a filament glowed white-hot, wasting most of the energy as heat. Fluorescent lights improved efficiency by using mercury vapor to produce ultraviolet light, which then excited phosphors to glow visibly. But the real revolution came with light-emitting diodes, or LEDs, where electrons recombining with electron holes release energy as photons of precise wavelengths. This quantum electrical alchemy now illuminates our cities with unprecedented efficiency. Its blue LEDs, whose invention earned the 2014 Nobel Prize in Physics, combining with phosphors to produce warm white light. These transformations extend beyond simple illumination. Lasers, light amplification by stimulated emission of radiation, represent perhaps the purest expression of electromagnetic alchemy. By carefully stimulating atoms to emit photons in perfect synchronization, we create light of extraordinary coherence and focus. This technology reads DVDs, performs delicate eye surgery, measures the distance to the moon, and may one day enable fusion power, all from harnessing the quantum mechanical properties of how atoms and light interact. The most profound alchemy occurs in nature itself. Photosynthesis, the original solar power, converts sunlight into chemical energy with near-perfect quantum efficiency, fireflies produce cold light through bioluminescence, with almost no energy wasted as heat. The aurora transforms solar wind particles into shimmering curtains of colored light. Even human vision is a form of electromagnetic alchemy, where retinal molecules change shape when struck by photons, initiating the cascade of neural signals we perceive as sight. As night falls and artificial lights begin to glow around you, consider this alchemical miracle. The energy now illuminating your room may have begun as sunlight on a solar panel, or as motion in a distant turbine, induced by that same sunlight's effect on weather patterns. The photons from your lamp are newly created, but their energy is ancient, a transfer from the electromagnetic fields that permeate all existence. You are surrounded by and participating in this endless cycle of transformation. Light becoming electricity, becoming light again, in an eternal dance that powers stars and civilizations. Hidden beneath the surface of our visible world, electromagnetic forces act as the unseen architect of reality, shaping atoms, building molecules, governing the very structure of matter itself. This is the deepest layer of our electromagnetic story, where we discover that these waves and fields are not just phenomena in the universe, but the very mortar holding existence together. The first clue to this profound truth came from the simplest of observations. Why don't atoms collapse? If electrons orbit atomic nuclei, they should radiate energy and spiral inward. Yet matter remains stable. The solution emerged from quantum mechanics. Electrons exist as standing waves around nuclei, their wavelengths precisely fitting orbital circumferences. This wave nature, governed by electromagnetic interactions, creates the stable electron shells that determine chemical properties. The entire periodic table, the diversity of elements that build our world, emerges from these quantum electromagnetic patterns. Chemical bonds themselves are electromagnetic phenomena. When atoms share electrons, covalent bonds, or transfer them, ionic bonds, it's the electromagnetic attraction between positive nuclei and negative electrons that creates the connection. The delicate dance of electron orbitals, their overlaps and repulsions, determines whether molecules will form and what shapes they'll take. The double helix of DNA, the folding of proteins, even the crystalline structure of salt, all are expressions of electromagnetic interactions at the atomic scale. These forces scale up to shape our everyday world. The hardness of steel comes from electromagnetic interactions between iron atoms and carbon impurities. The transparency of glass results from its atomic structure not absorbing visible light photons. The fluidity of water emerges from the polar nature of H2O molecules and their hydrogen bonds. What we experience as material properties are, at root, manifestations of electromagnetic fields and quantum mechanical behavior. Even life's complexity arises from these foundations. Enzyme catalysis relies on precise electromagnetic interactions between molecules. Neural signals propagate as electrochemical impulses. Voltage changes across cell membranes. The folding of proteins into functional shapes is guided by electromagnetic interactions between amino acids. At every level, from biochemistry to ecology, life is an electromagnetic phenomenon, a temporary local reversal of entropy powered by sunlight's photons. As you lie in bed tonight, consider this. The pressure of the mattress against your body is electromagnetic repulsion between atoms, preventing them from merging despite the incredible emptiness within matter. The warmth of blankets is infrared radiation from your body being trapped. Even your sense of touch is ultimately electromagnetic, nerve cells detecting pressure and temperature changes through ion flows. The solid, tangible world you experience is an electromagnetic illusion, a stable pattern in quantum fields that your senses interpret as substance. We are electromagnetic creatures living in an electromagnetic universe, our bodies and minds arising from the same fundamental forces that shape galaxies. The boundary between physics and biology, between matter and mind, grows thin when viewed through this lens. You are not just made of stardust. You are stardust organized by electromagnetic forces into temporary thinking configurations of the cosmos itself. As our journey through the electromagnetic spectrum draws toward its conclusion, we arrive at the mind-bending realization of all, that electromagnetism doesn't just describe the universe, it reflects the universe back upon itself in an infinite hall of mirrors where observer and observed, subject and object, creator and creation become indistinguishable. This is where science meets mysticism, where measurement merges with meaning, and where we confront the astonishing truth that in an electromagnetic universe, perception is participation. The first glimmer of this truth came with the discovery that light behaves differently when observed. The quantum measurement problem, where particles seem to choose wave or particle behavior based on whether we're watching, suggests that at fundamental levels, observation affects reality. Your eye detecting a photon isn't passive reception, but an interaction that completes a quantum process. The universe seems to require observers to manifest its full reality, a notion that echoes ancient philosophical traditions while emerging directly from electromagnetic science. This participatory quality extends through all our electromagnetic technologies. A radio telescope doesn't just detect cosmic radio waves, its very presence as an observer affects what can be detected. An MRI machine doesn't simply image the brain, its magnetic fields alter atomic spins to produce the signals it measures. Even your smartphone camera doesn't passively record light, its sensors absorb photons, destroying them to create digital information. Every act of electromagnetic observation is also an act of transformation. The implications ripple outward. The photons from distant stars that now strike your retina have traveled millions of years uninterrupted, until this moment when their journey ends in your perception. In that instant, you become the endpoint of an ancient electromagnetic story, the universe observing itself across time and space. The cosmic microwave background, radiation, the afterglow of the Big Bang, has been streaming through space for 13.8 billion years, waiting for intelligent life to develop instruments sensitive enough to decode its message. We are not just studying the universe. We are the universe's way of understanding itself. This reflective quality manifests most beautifully in our electromagnetic creations. The internet, that vast web of light and information, has become a sort of global nervous system, mirroring in technology the neural networks of our brains. Our satellites and telescopes extend our senses across the solar system, just as microscopes and particle accelerators extend them inward to quantum scales. The electromagnetic technologies we've created are, in a very real sense, the universe developing new organs of perception, tools for seeing itself more clearly. This final electromagnetic paradox, the same physics that enables objective measurement, also reveals that pure objectivity may be impossible. The observer is always part of the system. The measurer always affects the measured. In an electromagnetic universe, we are neither separate spectators nor omnipotent controllers. We are participants in a grand, luminous dance where seeing is touching, where knowing is changing, and where the light that reveals the world is also what creates it. And so we end where we began, with wonder. The story of electromagnetic waves is ultimately the story of consciousness awakening to its embeddedness in a universe far stranger and more beautiful than we ever imagined. From the quantum flutter of atoms to the slow radio wail of colliding galaxy clusters, from the photons crossing your closed eyelids to the memories forming in your dreaming brain, all are notes in the electromagnetic symphony that began with the first light of creation and continues in every moment of perception. Rest now, luminous being. The waves will continue their endless dance, whether watched or unwatched. The universe will keep whispering its secrets to those who listen across the spectrum of light. And tomorrow, when you awaken to a new day, remember, You are both the audience and the performer in this grand electromagnetic theater of existence. This completes our extended exploration of how electromagnetic waves changed our lives. From their fundamental physics to their philosophical implications, from technological revolutions to cosmic connections, we've traced how these invisible vibrations transformed every aspect of our existence. Thank you for listening, and may your dreams be filled with the quiet wonder of an electromagnetic universe.